Hello, Math 45 students. We are going to pick up on page 1, section 7.1, which is all about the systems of linear equations in two variables. So whenever you have two lines, when you graph them, you have three different outcomes that can take place. Either it's independent, meaning the two lines cross at a single point. That single point is the solution, therefore it's independent. We can say it's independent, and we can also say that the system is consistent. And inconsistent means that there's parallel lines, so the lines do not meet, so there's actually no solution. And a dependent line means there's, even though you see one, it's really one line on top of the other. So there's two lines that are dependent because it's one on top of the other. So you can actually say that they are going to be infinite solutions, because they cross at 1, 2, 3, 4, 100, a million, a billion different places on that line. Each line has an infinite amount of points on it. So if two lines overlap, there's an infinite amount of points that overlap, therefore infinite solutions. So let's start off by determining whether the ordered pair is a solution to the given system of equations. So we want to know whether or not this ordered pair 5, 1 is a solution to the system, which means that we're just going to plug in that ordered pair, that xy value, into both equations and see if we come out with a true or false statement. So we know that we have x is equal to 5 and y is equal to 1 for our ordered pair. So for our first equation, we have x plus 3y is equal to 8. So the x value that I'm plugging in is 5. The y value that I'm plugging in is 1. Does that, I'm not sure, equal to 8? Well, here 5 plus 3 times 1 is 8. So it definitely works for the first one. It is true. So now we are going to try for equation number 2, see if that works. Well, we have 2x minus 9 is equal to y. So 2 times our x value minus 9, does that equal our y value of 1? We are unsure. So we would get 10 minus 9, which is 1, is equal to 1. So that's also a true statement. So it works for both. So since it's true for both, we are going to say that 5, 1 is a solution to the system. It works out. Well, let's see if we can do the same thing for part B. So for part B, we have our x and our y values. So here's our x, here's our y. So here we have that x is equal to 8 and y is equal to 5. So for our first equation, we have 5x minus 4y is equal to 20. So 5 times that x value of 8 minus 4 times that 5 value for y. We are wondering whether or not that's going to equal to 20. So here I would have 40 minus 20, which is 20. So that is true. It works out perfect. Now let's see what happens in our second equation. So we have 2x plus 1 is equal to a 3y. So 2 times our x value, which is 8, plus 1. Does that equal to 3 times my y value, which is a 5? So let's see. We are going to get a 16 plus 1, which is 17. And 3 times 5 is 15. So 17 plus 15, those are not equal. So this was not equal. This was false. So what we say is that the ordered pair 8, 5 is not a solution Okay. So let's go ahead and go to our next example. So here we have 2x plus y is equal to negative 8 and x minus y is equal to negative 1. We want to know what happens when we graph. So yes, there's different ways of solving this system, but it specifically says to graph in order to solve. So we need to graph. And remember, whenever we graph, we put it into that y is equal to mx plus b form, where we have m is our slope. That would be your rise over your run. And you also have your b value, which would be your y-intercept. Okay? And you always start at the y-intercept. So let's go ahead and look at our first equation. We have 2x plus y is equal to negative 8. So the first thing I want to do is make sure that I get that y isolated. So y is equal to a negative 2x minus 8. So here my b value is negative 8. So then that tells us that the y-intercept is 0, negative 8. That is going to be the first ordered pair that I write. Now I can tell you that my slope is negative 2 over 1. So I can go down 2 and to the right 1, or I can go up 2 and to the left 1. So from that slope, if I go down 2 and over 1, I'm here. I also could have gone up 2 and to the left 1. Okay. And now I'm going to do my best to draw a line here. So please keep in mind that I'm writing this on my notepad. And I don't have a ruler, but more or less that's the idea that we want to get to. So now what we want to do is we want to do the exact same thing for equation number 2. So for equation number 2, we have this. So I'm just going to move this over to the side. So then I have equation number 2, which is x minus y is equal to a negative 1. So negative y is equal to a negative x minus 1. So y is equal to x plus 1. So here, my b is positive 1, which tells me that the y-intercept is going to be 0, comma 1. My slope is 1 over 1, so I can go up 1, right 1, or I can go down 1 and left 1, okay? So remember, our starting point is going to be 0, comma 1. So that's my starting point. And my slope tells me to go up and to the right 1. I also could have gone down and to the left 1. So if I zoom in a little bit more, I'm going to connect my dots. And let's inspect what's happening here. Well, do the lines cross, don't cross, or overlap on every single point? Well, in this particular case, we have it so it intersects in one special point. That one special point where they overlap is negative 3, comma, negative 2. So that is going to be my solution. So the solution ends up becoming the ordered pair where they intersect. Another thing that you can say, because these are independent and consistent system. Since both equations meet up and intersect at one place, okay? All right. So let's go ahead and do this for part B. So let's take a look. So equation number 1. I have my 2x minus 5y is equal to a negative 25. So I want to get the y by itself. So I'm going to have a negative 5y is equal to a negative 2x minus 25. I'm going to divide by negative 5. So negative 2 divided by negative 5, a negative divided by negative is a positive. So I have my 2/5 x. Remember, I'm dividing by negative 5. So a negative divided by negative is a positive. So 25 divided by 5 is going to give me a positive 5. So here, my b is going to equal to 5, which tells me my y-intercept is 0, 5. My slope is a 2/5, so that means I can go up to the right 5, or I can go down 2 and to the left 5. So from that y-intercept, from there, go up 2 and over 5. Or I could have gone down 2 and over 5. And so now, more or less, I have my line. Okay. Now, I'm going to try to do the exact same thing for equation number 2. So for this equation, I have a negative 4x plus 5y is equal to 35. So then 5y is equal to a positive 4x plus 35. So y is equal to a 4/5 x plus, and 35 divided by 5 is going to give me 7. So my b is 7, so that y-intercept is 0, 7. So that is going to be the first ordered pair that I draw. Now my slope is a 4/5, so that means I'm going to go up 4 and to the right 5. Or I could go down 4 and to the left 5. So that is what my graph looks like. So it looks like I have a green dot and a blue dot that overlap. And that overlap is right here at that ordered pair. So that overlap ordered pair would be a negative 5, positive 3. So my solution is negative 5, 3. Again, what I would say about this system is that it's independent and consistent. Okay. Well, hopefully you guys are getting the hang of this. Now, let's move on to the substitution method. So you still have a system, but now we're not using graphs anymore. Instead, we're going to be using something called the substitution method. So using the substitution method, we have that x is equal to y plus 3, and 4 is equal to 3x minus 2y. So what we really do is plug one equation into the other. So notice how the x variable is isolated. So this y plus 3 represents all of x. So that's what I'm plugging into that equation. So I have 4 is equal to 3x minus 2y. So 4 is equal to 3. And so now I'm plugging in the x variable. So that represents the y plus 3. And I have my minus 2y. So now when I distribute, I would have a 3y plus 9 minus 2y. So if I were to combine like terms, 3y minus 2y gives me 1y. And if I were to subtract 4 on both sides, so 4 minus 9 gives me a negative 5. So far for my ordered pair, I need an x value and a y value. So the only thing I have right now is my y value. So now I need to plug this in to find x value. So to find my x value, you plug it into whichever equation you want. So I don't know, maybe I'll just use the first one. So x is equal to y plus 3. So x is equal to, and that y value that we have is a -5 plus 3. So -5 plus 3 is a -2. So now I have my x value as a -2. So my solution is going to be -2, -5. The x value is -2, my y value is -5, and I have to make sure that I write that as an ordered pair. Okay, now let's look at part B. When I'm looking at part B, I definitely want to isolate one of the variables. So maybe it could be best if I were to isolate the y in the top equation. So then y would equal to a positive x minus 5. That means that the y is isolated. So this is what y represents. So I'm going to plug that into my y variable. So I have 2x minus 5y is equal to 1. So I have 2x minus 5. Okay, this is where my y is. So that's x minus 5, since I'm doing the substitution, equal to 1. So then from here, I need to distribute. So 2x minus 5x plus 25 is equal to 1. Combining like terms, 2x minus 5x is a -3x. And if I were to subtract 25 from both sides, 1 minus 25 is a -24. And don't forget, since this is multiplication, the way to undo multiplication is by division. So I'm going to divide both sides by -3 to get the x isolated. So 24 divided by -3 is going to give me a positive 8. So I'm going to write that down as a positive 8. So far I have only half my solution. So now I need to figure out what my y value is going to be. So find y value use x is equal to 8. So I already know from my top equation that y is equal to x minus 5. So y is going to equal to that x value, which is 8, and I'm going to subtract 5. So y is equal to a positive 3. So my solution here is going to be the x value and my y value. So 8, 3 ends up becoming my final answer. Okay. Now for part C, this one's really nice because the x is already isolated. Perfect. Since the x is isolated, this is what x represents. So that is what I'm going to plug in. So I have x plus 2y is equal to 13. So the x value that I'm plugging in is 9 minus 2y. And I have plus 2y is equal to 13. Well, what happens here is that the 2y's cancel, so I'm left with a positive 9 is equal to 13. Can you have $9 and $13 at the same time? No. Those are two different values. So you would say no solution. If you're thinking about the system would be independent, and these would also be parallel lines. But since we're solving by substitution, it's enough to say that it's no solution. Okay, now moving on to part D. So for part D, again, you want to isolate the variable. So maybe the nicest thing to do here is to isolate that y variable. So I'm going to add 2x to both sides. So y is equal to now a positive 2x plus 5. So now that I have the y isolated, that's what the y is equal to, I'm going to plug that into my y variable. So I have a negative 3y plus 6x is equal to a negative 15. So negative 3, okay, so here's my y value. I'm going to plug in 2x plus 5 plus 6x is equal to a negative 15. So when I distribute, I'll have a negative 6x minus 15 plus 6x is equal to a negative 15. Well, this is nice. The negative 6x and the positive 6x cancel out. So you're left with a negative 15 is equal to a negative 15. And if you can't see it yet, that's fine. You can add 15 to both sides. So that way maybe, hopefully, you can really see that 0 is equal to 0, right? Negative 15 is equal to negative 15. That means both numbers are equal to each other. Just like 0 is equal to 0 means both numbers are equal to each other. So when this happens, you're going to say that there's an infinite amount of solutions. The reason why it's an infinite amount of solutions, that even though both these equations look completely different, it's really the same equation. It's one equation on top of the other. So it would be a dependent system, okay? Also, it's not just enough to give me that it's an infinite solution. You also have to write it as an ordered pair. So as an ordered pair, the x comma y, well, the x is independent, so I leave that alone. And the y value, well look, y is in terms of x. So since y is written in terms of x, you can just use that equation. So you can say that the y value is really just 2x plus 5. And that's what we use for the substitution. So in your homework, it's going to ask you for that ordered pair, and now you know how to give that ordered pair. Okay. Now for the next section, it wants you to solve the system by either using the addition or the elimination method. And really, those names are just interchangeable. Some people like to say addition, but then technically you can subtract. So some people just say elimination to say that you can either add or subtract both equations. Personally, for myself, I think it's easier to add than to subtract. So I would just add them together. So let's just call this the addition method. But if you said elimination method, that's perfectly fine. So look at your variables. Your goal is to cancel one out right from the beginning if you can. So notice if I were to add these together, 2y plus 1y, that gives me 3y. That doesn't cancel it out. But if I have positive x and negative x, it does cancel out. So that's great. So if I were to add these two equations together, the positive x and the negative x cancels out. So then you would be left with a 3y, and negative 1 plus 3 would give me a positive 2. So you would get that y is equal to 2/3, okay? Perfect. So now that I have that, now I'm going to plug that in to get my x value. And I find my x value by using my y value that I just found. So I'm going to use, doesn't matter, but I'm going to use the second equation. So negative x plus y is equal to 3. So I have negative x plus that y value I just found was 2/3. And this is equal to positive 3. So negative x is equal to 3 minus my 2/3. And if you're uneasy about fractions and addition and subtraction, you're more than welcome to use a calculator. So 3 minus my fraction of 2/3. Now I'm going to get 7/3. So negative x is equal to 7/3. So we never want that negative out in front. That makes it not isolated. So in order to isolate that x variable, I'm basically multiplying each side by negative 1, which would give me a negative 7/3. So my solution is a negative 7/3 because that's my x value, and my y value of 2/3. And you always want to make sure to write your answer as an ordered pair. Now, when I look at part B, I'm looking at that and I'm like, okay, well, look at the x's. If I add them together, it won't cancel. If I add my y's together, that doesn't cancel either. So what I'm forced to do is to find an LCD. So look at my x's. If I have 2 and 5, what would be my LCD? It would be 10. So for that first equation, I'm going to multiply everything here by a negative 5. When I do that, I get a negative 10x, a negative 15y, and negative 5 times a negative 16 ends up becoming a positive 80. Now, for my second equation, remember my goal is to cancel out the x values. So 5 times a positive 2 will cancel out that negative 10 that I have chosen up ahead. So that will give me a positive 10x, a negative 20y, and 30 times 2 would be 60. And now I can add those equations together, and the x's cancel, which is really nice. So negative 15 and negative 20 is a negative 35y, and 80 plus 60 will give me 140. Now dividing both sides by a negative 35, I'm going to get a negative 4. So now, again, I need to find my x value. So I'm going to plug it into one of my equations. It can either be the top one or the bottom one. So let's go ahead and choose the top one. So I have a 2x plus 3y is equal to a negative 16. So 2x plus 3. And my y value here is a negative 4 that I'm plugging in. So I get 2x minus 12 is equal to a negative 16. So negative 16 plus 12 would give me a negative 4. So x is going to give me negative 2. So my x value is negative 2, and my y value is negative 4. And so that would be my final answer for part B. Okay. Well, let's look at the second equation, or C equation. I have 2y minus 2x is equal to 2. And down at the bottom, I have 2y minus 2x is equal to 6. So you might be thinking, oh, hey, these are really strange. But if I were to add them together, nothing will cancel out. So let's just manipulate the first one by multiplying it by a negative 1. When I multiply that by a negative 1, I get a negative 2y plus 2x is equal to 2. The second equation, I leave it alone, so I get 2y minus 2x is equal to 6. When I add them together, the y's cancel and the x cancel, so that's 0. But don't forget to add the 6 and the negative 2, right? That's a negative 2. I forgot to distribute that negative to that 2. So my negative 2 plus 6 is going to give me a positive 4. 0 is the same as 4, or 4 is the same as 0. That doesn't make any sense. So you would say no solution. Okay, this system is inconsistent. All right. So let's take a look at letter D. So if I'm looking at letter D, let's say I want to cancel out the x values. So that means that I want to go ahead and multiply the first equation by negative 3. So I would get a negative 3x, negative 9y. And don't forget, it's a negative 3 times 2, so it's a negative 6. And down at the bottom, that did not change, so 3x plus 9y is equal to 6. So if I were to add that together, the x's cancel, the y's cancel, so that's 0, that's great. But now the 6 and the negative 6 also cancels. So this is 0 is equal to 0. So now that I have that 0 is equal to 0, well, that's fantastic. Now I know that I'm going to have infinite solutions. So now my goal is to really write one of those equations in y equals mx plus b form. So let's say I have x plus 3y is equal to 2. So then 3y is equal to a negative x plus 2. So y is equal to a negative 1/3 x plus 2/3. So my solution, remember, I want to write it as an xy ordered pair. So the x is here, and the y, we're going to write it as a negative 1/3 x plus 2/3. Okay. Well, I do hope that this is making sense. And if it's not, it's okay to contact me, contact the Math Success Center. There's a lot of resources for you guys. So please don't be shy in asking for help. Now, our next example. Given the cost function and the revenue function, find the break-even point and the profit function. So there are two different things going on here. So the first one is the break-even point. So if I have the break-even point, I have a certain formula for that. That formula is going to be C of x is equal to R of x. So my cost function is equal to my revenue function. So the cost function that I have is a 0.85x plus that 35,000 equal to my revenue function, which is that 1.55x. So now I'm going to subtract that 0.85x from 1.55, and I would get a 0.7x. Now, if I were to divide 0.7 from both sides, I would get 50,000. So break even would be making 50,000. Now, the next thing I want to consider is the profit function. So over here, I'm going to consider my profit function. So for my profit function, my P of x, that's going to equal to my revenue function minus, and I always like to put brackets, it's going to minus my cost function. And the reason I put brackets is because a lot of students forget to distribute. So you can even put a -1 there so you know that you're going to distribute. Or you can just remember that you are going to just subtract. Okay? So, all right. So here we go, my profit function. So P of x is equal to my revenue function. So that would be the 1.55x minus my cost function, and that cost function was 0.85x plus that 35,000. So when I distribute, that's a negative 0.85x, and it's also a negative 35,000. So I'm going to get my P of x is equal to 1.55x minus 0.85x is going to give me my 0.7x minus my 35,000. So that is going to be my profit function. Okay. All right. Now for my next example, it's a word problem. It says the cost of a ticket to the circus is $25 for children and $50 for adults. On a certain day, attendance at the circus is 2,000 and the total gate revenue is 70,000. How many children and how many adults bought tickets? So for this one, it kind of depends on what type of learner you are. You can either put this into a chart or you can kind of make sense of it. It's kind of your thing. So if I were doing it, this is how I would do it. So I know that I'm talking about children's tickets. So I'm going to say C is going to be my child ticket. I like to label. And I also have that I have adults. So A is going to equal to my adult tickets. So the first equation is going to be representing your amount. So I have the amount of the child tickets plus the amount of the adult tickets, and the total amount would be 2,000. Now, my second equation is going to represent money times my amount. So I definitely still have C plus A, but every child ticket cost a certain amount. Every child ticket cost $25. And every adult ticket costs $50. I'm just going to give myself more room. So every adult ticket cost $50. And the total amount of money here is here. So that's going to be my 70,000. So now I have a system of two equations. So I can either do a substitution or I can do elimination. For this one, why not we do substitution? Why not? So let's get the C by itself. So C is equal to my 2,000 minus A. So I have my equation of 25C plus 50A is equal to my 70,000. So if I'm doing my substitution, remember, I'm plugging in for my C value. So I'm going to have this as 25, and that C value that I'm plugging in is 2,000 minus A. And I have plus 50A is equal to my 70,000. So now, when I distribute, and I just have my calculator in my hand, even though you can't see me, 25 times 2,000 is going to give me 50,000. Minus my 25A plus 50A is equal to my 70,000. So now what I want to do is I want to combine negative 25A and 50A. So that's going to give me a positive 25A is equal to my 70,000. From there, I'm going to subtract 50,000 from both sides. So 70,000 minus 50,000 will just give me 20,000. And if I divide both sides by 25, I'm going to get 800. So remember that A represented my adults. So I'm going to have 800 adult tickets. But I am not done. I also need the amount of my children's tickets. So we are going to figure out the amount of children's ticket. So the equation that I have before is C plus A is equal to 2,000. So the C I don't know, but the A value that I have found was 800. So now I'm going to do a subtraction. So I'm going to have 2,000 minus my 800, which is going to give me 1,200. So then I have 1,200 child tickets. Okay. Well, I hope that this is making sense and I haven't lost anybody yet. But if I have, please make sure to email me, okay? And that is how we answer this question. How many children and how many adults bought tickets? 800 adults bought tickets, and the amount of child tickets bought were 1,200. Okay, thank you guys.